Hi there, and welcome to this lesson on Pure Mathematics 1, Chapter 1. We're up to 1.3 and factorizing. Now, a little bit on inverse functions. Nearly all functions have inverse functions, and they are the complete opposite of the original function. However, the inverse function is almost invariably more difficult to use than the original function itself. For example, plus is a function, which is very straightforward. Slightly more confusing is taking away, which is the inverse function to addition. Times is a function. Again, slightly more confusing is division, which is its inverse function. In the same way, you can think of expanding brackets, multiplying out brackets, as a function. Factorizing is the inverse. It's the complete opposite of multiplying out brackets. So when you expand brackets, you multiply everything in the brackets together and get lots of separate terms. When you factorize, you do the complete opposite. You start with lots of separate terms and you try and put them into brackets. Now I'll let you have a go at these first questions first of all, and then we'll go through them together. So pause the video and then restart it once you've done these. Okay, we'll quickly go through them. The first question, 5 is common to both terms, so it's the 5 that goes outside the brackets, x plus 4 inside. The second question is x that's common to both terms. The third question, both 3 and x are common to both terms, so they go outside the brackets, leaving us with 3x plus 4 inside. The fourth question, 3x and y are all common, so they go outside, leaving us with 6x plus 7y inside. And the fifth question, 7x is common to both, which leaves us with 2x minus 3y inside. The sixth question, 3xy is common to both. Just be a little bit careful on this one. 3xy times by 1 gives you 3xy, so it's 1 that'll go inside the brackets on that question. Factorizing quadratics, various methods exist. If you're good at algebra, then the truth is you can factorize a quadratic just by in your head predicting what two brackets would multiply together to give you that quadratic expression. The more practice you get at these things, the better you do get at them. So for instance, if you had 2x squared minus x minus 6, you know the brackets must begin with 2x and x, nothing else makes sense. 3 and 2 or 6 and 1 are the only two possibilities. So you would consider 3 and 2 as a possibility, you would consider 6 and 1. And then you've got to consider the possibilities with pluses and minuses. Now in this case, if you had 2x plus 3 times x minus 2, that does the job. You get 2x squared. It's the middle two terms that you always need to keep an eye on. You get minus 4x plus 3x, and that gives you the minus x that you want. And 3 times the minus 2 is minus 6. Now, if you're not so good at that, then there is a formal method that does always work well. Still can be a little bit tricky with harder numbers, but the method does work. The general quadratic, ax squared plus bx plus c, for example, 2x squared minus x minus 6. What you find are two factors of ac multiplied together, that will add together to give you b. Now, AC is equal to 2 times minus 6, which is minus 12. B is minus 1. So you're looking for two numbers that multiply, two factors, of AC, that when you add them together, they will give you minus 1. And you don't need to look too far before you stumble on 3 and minus 4. 3 times by minus 4 gives you minus 12. And if you add 3 and minus 4 together, you get minus 1. Once you've found the two factors, you then split up this middle term, the bx term, or the minus x term in the question. Using those two factors, making sure you use the plus and minus signs correctly as well. So 2x squared minus x minus 6, this minus x gets split into 2. It gets split into plus 3x minus 4x. Plus 3x because of the 3 we had here, minus 4x because of the minus 4 we had there. Once you've done that, you then factorize each pair in the normal way, and it doesn't matter which order you write these two middle terms in, it'll work either way. If I write them this way around, then I can take x out. That'll give me 2x plus 3. This pair, I can take 2 out. That also gives me 2x plus 3. It's at this point you know if you're doing it right. You should get exactly the same term in both brackets. You then factorize again, taking out the common pair. And the common pair is 2x plus 3. So we need x from here, and we need minus 2 from there. And if we multiplied that, we would get this. Okay, 3 questions for you to have a go at. They gradually get harder as you go down. Pause the video, then come back when you are ready. Okay, we'll look at question 1 first of all. X squared plus 3x minus 10. So if we multiply a and c together, 1 times minus 10 is minus 10. B is 3. So we're looking for 2 factors of minus 10, that when you add them together, you get 3. And do keep the minus in. So it could be 1 times minus 10 or minus 1 times by 10, and so on and so on. In this case, 5 and minus 2 work. 5 times minus 2 gives us minus 10. And if we add 5 to minus 2, we get plus 3. Then we split up the middle term, the 3x, using these. So the 3x becomes 5x minus 2x, using the 2 factors. And then we factorize each pair. Again, it doesn't matter the order you write these down in. The first pair becomes x into x plus 5. The second pair becomes minus 2. And that should be x plus 5. Yeah. That is a mistake. If you had minus 2 times plus 5, you would get the minus 10. So that bracket should also have x plus 5 in. And then you get x plus 5 times by the x from here and the minus 2 from there. So it's the correct answer. It's just the working out that's gone wobbly. The second question, 2x squared minus 11x plus 5. If we multiply an a and c together, we get 10. B is minus 11. We're looking for 2 factors of 10 that will add together to give us minus 11. Now, the 2 factors of 10 are minus 1 and minus 10. Minus 1 times by minus 10 gives us 10. If we add minus 1 to minus 10, we get minus 11. Looking at the middle term, that splits up using these 2 numbers. So the minus 11x splits up into minus x and minus 10x. Then we factorize. The first pair would factorize into x times 2x minus 1. The second pair would factorize into minus 5 times 2x minus 1. Thankfully, they are the same this time. 2x minus 1 is common to both terms, and we take the x from here and we take the minus 5 from there. Question 3, a times c is 12 times minus 6, which is minus 72. B is the middle number, that's 1. So we're looking for 2 factors of 72 that multiply together to give us minus 72. And when you add them, you've got to get 1. Lots of possibilities with 72 because it has so many factors. So it can take a little while to discover it's minus 8 and 9. Minus 8 times by 9 is minus 72. And if I add minus 8 to 9, I do get plus 1. And then we split up the middle term in the same way. Minus 8x plus 9x. Doesn't matter the order. It'll work either way round. Factorizing the first pair gives us 4x into 3x minus 2. The second pair, 3 into 3x minus 2. We've got the same thing in both brackets, so all is well. That is the common term. We take 4x from the first one, plus 3 from the second one, and that is the answer. Now, the difference of 2 squares is a very particular type of factorizing, which works when you have something squared, take away something else squared. It's a special case. You do need to keep an eye out for it in A-level. It turns up a lot. X squared minus y squared can always be written as x plus y times by x minus y. The 2 middle terms cancel each other out. You get a plus xy and a minus xy, and they cancel out. There's the plus xy, there's the minus xy. So you just get x squared minus y squared. It does not matter what these things are, as long as they are both something that can be squared. So something more complicated like that, 9x squared can be written as something squared, and this expression can be written as something squared. So that can be written as 3x all squared, and that can be written as 4a squared b cubed all squared. As long as you can do that, you just follow the same pattern. Sorry, I don't know why it went back there. So we were up to here. You do the same thing as we did before. You add the two things together, and you do one take away the other. So the first thing plus the second thing in the first bracket, the first thing take away the second thing in the second bracket. Okay, 3 questions for you to have a go at. Pause the video and try and do those. All right, we'll go through them together. X squared minus 36. You're square rooting both things. So the square root of that is x, the square root of that is 6, which gives us x plus 6 times x minus 6. Same here, the square root of that is 2y, the square root of that is 5w. 1 is plus, 1 is minus. The square root of that is xy, the square root of that is 7x squared y cubed. 1 is plus, 1 is minus. 3 more examples, a little bit of a mixture of things. Have a go at those. Some of them have extra bits that you need to do that you might miss. Pause the video, start it again when you're ready. Okay, going through these. The first question, no tricks or catches on that one. X squared goes into both terms. 3x minus 5 would go in the brackets. The second one does have a trick. The first thing you need to notice is that y goes into both terms, so you can factorize taking y out. Once you've done that, you've got the difference of 2 squares in here, because you've got y squared minus 6 squared. That will factorize into y plus 6 times by y minus 6. The third question, first thing to notice is x goes into each term, so you'll take x outside. Once you've done that, you get a quadratic inside, and it isn't obvious, but that quadratic does factorize, so you can take it further. The quadratic in the bracket there factorizes to 2x minus 1 times by x minus 5. That gets us to the end of the lesson. Go to page 8, exercise 1C. Thank you very much for attending, and cheerio.